The question states a given function defined from real numbers set R to -1 by 2 to 1 by 2 in closed brackets. The function is defined as x upon 1 plus x square, and we need to tell if the function is injective, surjective or invertible. Let's see the solution. The equation given is fx upon is equal to x upon 1 plus x square. Thus, the most appropriate method to know if the function is injective is to check if the first order derivative of the function changes its signs at any intervals. So, the first derivative of the function is 1 plus x square into 1 minus x into 2x upon 1 plus x square, which when solved gives the equation 1 minus x square upon 1 plus x square whole square. Seeing the numerator, we can surely say that the total value of the function would change its value at different intervals. So thus, it is not injective. Coming down to the second part, that is surjective. Surjective means that the given codomain is equal to the range of y, range of the function. Thus, to find that, we express the functions in terms of y, stating y equal to x upon 1 plus x squared is the given function. We change the values such that we can express the function in terms of y. We do that by cross multiplying the denominator and taking the numerator on the other side of the equation, giving the equation yx square minus x plus y equal to 0. Now, to find the range of y, we use the discriminant method, which is the discriminant is equal to b square minus 4ac. We apply the formula into the equation. Gives us d equal to 1 minus 4y square, which will be greater than or equal to 0. Thus, from this equation, using the inequality stated here, we can say y is an element of minus 1 by 2 comma 1 by 2 close brackets minus 0. Well, explicitly, when we put y equal to 0, x is also equal to 0. Thus, 0 is also a part of the range. Now, if we check minus 1 by 2 and 1 by 2, this is same as the range and same as the codomain. Thus, we can say the function is surjective. The answer would be surjective but not injective.